Getting started with section 2.3 functions. Question number 1, we're asked to determine the domain and range of the relation and tell whether the relation is a function. For the first part, the domain is the list of all of the x values where each of these points here is ordered pairs is given, you're given an x value and a y value. So the domain is the set of all the x values that you see in each point, including 15, 20, 31, 15, and 55. The range would be all of the y values. In each of the points we have, oh, by the way, we probably don't need to write this 15 twice. We only need to list that value once in the domain. Now the range is all the set of y values, including 8, -7, 8 again, we don't need to list it again, and 10. So we see we have our domain and our range. We'll put that into the squiggly brackets, separated by commas. And the range, again, is all the y values. Separate those values with commas. Now we're asked to determine whether the relation is a function. If you have any repeated x values, then we can say that this is not a function. If you were to graph these points, any points that would have the same x value for different y values would indicate that the relation is not a function. If you do a quick sketch of the points, just do approximately over 15 up 8, and you see we have another point here over 15 up 10. That point would be above, and this relation would not pass the vertical line test. So we say that this is not a function. And you can determine just by looking if there are any repeated x values. You want to say that the relation is not a function. Question number 2. Determine whether the relation is a function and give the domain and range. Well, this is a mapping, and you can come up with the set of ordered pairs for this mapping. Every value on the left side is an x value, so that would be 22, which maps to a value in the second grouping. That's your y value, 24. 22, 24 is a point that's in the relation. 8, 18 is a point, and 18, 24 is a point. So you see that each of these x values maps to a y value. There's no single x value that maps to two different y values. So we say this is not a function. I'm sorry, this is a function because you have no repeated x values. So is this relation a function? Yes. And then we're going to list the domain. The domain is the set of all the x values and everything that's in this first grouping, which you have 22, oops, right here, 22, comma, 8, comma, and 18 are all the elements in the domain. And the range would be all the elements that are in the group of y's, which would be 24 and 18. Now the way I remember the domain and range is that in the alphabet, the letter D comes before the letter R. So domain comes before range. And in the alphabet, the letter X comes before the letter Y. Number 3, determine the domain and range of the relation and tell whether the relation is a function. When you're looking at a graph and trying to decide what the domain is on the graph how far to the left the graph goes and how far to the right the graph goes. Again, this is how we can talk about our domain. In this graph, the values continue forever to the left. This is a line that's going to continue forever. So forever to the left is negative infinity. And this graph is going to continue to the right. So forever to the right is positive infinity. That's our domain. And then in terms of the range is how low and how high the graph goes. It's low to high. This graph goes forever down. It's going to keep going down and down and down. The lowest y value that we're going to see is negative infinity. And then it's going to keep going forever up and up and up and up and up. So the highest y value is positive infinity. Select that and check your answer. And then how can we determine whether this graph is a function? A graph is a function if it passes a vertical line test. No matter where you draw a vertical line, it's only going to go through one point at a time. So we can say, yes, this is a function. Check our answer. Number 4. Determine if the graph is a function. Also give the domain and the range. Does this pass the vertical line test? You can draw a vertical line anywhere here, and it does go through 2 points. So we say this is not a function because it does not pass the vertical line test. To give the domain and the range, the domain is how far to the left the graph goes on the x-axis. The domain, if we look at this all way over here, it looks like this is the farthest to the left that the graph goes. And that x value is -4, and it touches -4, so we're going to use a bracket here for -4. And then along the x graph continues forever in this direction, starting here at -4 and moving forever to the right. This graph is going to continue going out to the right side of the graph. So this is domain of -4 to infinity, and including, because it actually touches -4. And then finally the range. The range, again, is how low and how high the graph goes. This graph on the y-axis, this graph is going to continue to go down and down and down, getting wider and wider and wider. So it's going to be negative infinity, and it's going to continue to go up and up and up, getting higher and higher and higher. So the range is from negative infinity to positive infinity. Number 5. We want to decide whether this relation defines y as a function of x and give the domain and range of the function. Here we could say this does define y as a function of x. In other words, we can write this as y equals something with an x in it. So the answer to the first part is yes, it is a function because we have y by itself equal to an expression that has an x in it. Let's check our answer. And then to determine the domain. The domain here is found by figuring out what possible x values you can plug into the function. When you're taking the square root, you cannot take the square root of a negative number. So you cannot take the square root of a negative number. So whatever's underneath the square root must be positive or 0. We're going to set up an inequality. We're going to say 5x plus 3 has to be greater than or equal to 0. It must be. If the whole expression 5x plus 3 was negative, then you would have the square root of a negative number, which ends up being imaginary, and that would not be part of the domain. So to determine the domain, set the part underneath the square root, 5x plus 3, to be greater than or equal to 0. When we solve this for x by subtracting 3 from both sides, we get 5x is greater than or equal to negative 3, and then dividing by 5, we get x has to be greater than or equal to negative 3 over 5. If you think about that on a number line, on the number line, we would locate negative 3/5 on the number line. We're going to put a bracket here, and the solutions are all the x's that are greater than, so it's going to be everything to the right. When we give our answer using interval notation, the left side of this number line starts at negative 3/5, and the right side of that number line ends at positive infinity. So that's how we're going to write our domain. Choose the infinity button from the palette. And anytime you have infinity as part of your domain or range, it's always going to have a parentheses next to it. Oh, I'm sorry, we were supposed to write a decimal value. So let's change negative 3/5 to 0.6. Okay. All right, and then to determine the range, if what you're plugging in here is 5x plus 3 has to be greater than 0. Let's do this. If we're saying that 5x plus 3 has to be greater than or equal to 0, then the square root of that has to be greater than or equal to 0. So, and that is actually what our y is. Our y must be greater than or equal to 0. So on the y-axis, the lowest that y could be is 0, and it's going to go up to infinity. So the way we would write our answer for that, for the range, is from 0 to infinity, and close the parentheses. Another way of working out the domain and range is by looking at a graph of this function y equals the square root of 5x plus 3. So with the graphing calculator, you can graph the function y equals square root of 5x plus 3 and look just to determine the domain and the range. Or at least this can help you check it. When you turn your calculator on, press the y equals button and clear whatever's in the spots. Make sure that none of those plots are shaded and everything is clear. And you're going to enter the expression square root of, and you can use parentheses here, 5x plus 3, close the parentheses, use the arrow to the right, and you can press, I do a standard graph, zoom 6, so you see the graph. Let me see if I can get a close-up of this, large. Okay, so it's not that easy to see that our graph here, I'm going to zoom into this, zoom 2 and enter. The graph begins here on the left side. When we talk about domain, it's the left side to the right side. So how far to the left does this graph go? It actually begins graphing at negative 0.6 and it continues forever to the right. So that's why our domain is negative 0.6 to infinity. The range, it starts at 0 and actually touches here, although the graph doesn't display that. It starts at 0 and goes to positive infinity. So it's just another way of checking the domain and range by looking at the graph.